Hopefully you can hear me now. Yeah, thank you, Lynn, for the introduction. I'm just going to talk a bit about when vision fails and how we can use other modalities such as audio and language to combat this. So as a start, I want to go through this example here where we're given 4 images with the following question of which of these images belong to the Atelocynus microtus species. And we can see from these images that there's a number of different animals. And what I'm hoping is that this represents an unseen class. So many of you don't know what this is. And basically this answering this question would just be 1 in 4 chance if it was a guessing game. However, when we look at language and look at a language prior, so I've just taken the first sentence from Wikipedia here, we see it says the short-eared dog, also known as the short-eared Zorro and small-eared dog, is a unique and elusive canid species endemic to the Amazonian basin. And I want to highlight 2 things here, primarily the Amazonian basin and the short-eared dog. And from this, we can see it's pretty clear that it's obviously the first image that is the class that we were looking for. And we know this because of 2 things, right? Because of the things that I highlighted. The Amazonian basin, which we know as humans, we've seen examples of rainforests before, and also dog. We can see kind of the outline of the dog here, and we recognize these attributes. So even though this was an unseen class, we can use attributes of this class to work out which is the correct image. In this second example, I want to kind of highlight this person closing a fridge, and let me just play this video. So you can see here someone's kind of closing their fridge and walking away from the fridge, but it's kind of not immediately obvious whether or not the fridge closes. And in this data set that we have, this happens quite a lot of times. And in some cases, people are just grabbing some ingredients and then they're going to go back to their fridge to grab some more ingredients. And it's hard to know whether or not the fridge is actually closing. However, when we add sound into the mix, add audio, hopefully you can hear it. It should be quite obvious now that because we can hear the fridge close, the fridge has actually been closed. So in this case, like audio has become something which is going to definitively tell us whether or not this action occurred. So what went wrong initially in these 2 examples? And in both cases, these were cases where vision failed. In the first case, you could recognize the types of the animals, you could recognize their attributes, but essentially this boiled down to an unseen class. And it was only when we added this extra information via language prior that you were able to solve this problem. And in the second case, because of the viewpoint from the first person nature of the videos, the action couldn't be seen, but it could be heard. And again, by hearing this, we were able to work out what the correct solution was. So with this knowledge, kind of what my work has been focusing on is kind of language and audio for video understanding. And I'm going to focus a bit more on language during this, this presentation today. And what we've kind of found out at Bristol is that audio can be applied like relatively easy for cases in action understanding or action recognition. And in most cases, you can use kind of something, extract some audio features and gain some like performance increases. However, when we think of language, it's not necessarily as clear how to use this modality. And so what do I mean by this is we've got another example here of a video, and I want you to think about what verbs you might use to describe this action. So like quite quickly, what might come to mind is something along with put and place. And I've grouped these together because these are quite synonymous when you think about them. In most contexts, put and place represent the same kind of meaning, the same action, and so they can be grouped together. You might also have thought of as insert as a possible verb. And in this context is correct, right? Because they're inserting a bowl into a stack of bowls or into the cupboard. However, when we think about it and compare this to put and place, these aren't necessarily synonymous. There are cases where insert is an example of put and place, and then some cases where it isn't an example. And then we can go further with a verb such as stack. And this is a very, very specific verb to use for this case, as again, we're specifically stacking the bowls in this example. And again, you already can't think of this as synonymous with put and place, and that represents a completely different verb in most scenarios. So when we think about this, we see that the boundaries between verbs are soft. And generally when we're thinking about classification, we're trying to group things together so that they're minimally overlapping classes. But in the case of language, due to the different contexts, we find that this is not the case. So for the same action, we find that different verbs or different nouns can be used. And then for different actions, we find that the same verbs and nouns can be used. So when we're looking at language and classification, we find this problem that kind of underlies both of them. And now, so I want to talk a bit about Epic Kitchens 100, which is a data set that we've released this year at the University of Bristol. And it's an extension of our previous data set. And I'll just play this, set this going. So one of the key things that we wanted for this data set is that includes audio and includes full audio and open vocabulary narrations. So when we were annotating this data set, we didn't ask any of our narrators to limit their choice of verbs and nouns. Instead, we gave them free rein to say whatever they wished. And this is where all the examples from the previous few slides for the videos have come from. And you can see here that even from the same participant, we see that they're using different nouns. In this case, someone says cut cheese and cut mozzarella. So they're using the different verbs and nouns for the exact same action. And with this, we kind of came up with a new task to highlight this issue, which is multi-instance retrieval. And this can be thought of as an extension of the video retrieval task. So this is quite similar to how you'd search on YouTube. You might give a caption in the search bar, and then you'd retrieve a video. And you can do this two ways, right? You can search a caption to retrieve a video, or not what YouTube does, but you can search with a video and retrieve captions. And this is exactly this example here. So we're given a video of someone placing their bread on a cooling rack, and then we want to retrieve captions which correctly describe this video. And we want to rank all of these in a way such that it's the most relevant at the top, and the completely irrelevant or least relevant at the bottom. So you can see here, the most relevant, I put bread on a cooling rack, and then maybe I put down bread, doesn't fully describe the action, but describe part of it. In this case, I return bread. The verb is perhaps used in the incorrect context, but is still, slightly relevant. Before I cut bread, where it's only the noun which is used here. And I say this is an extension of the video retrieval task, in that this video retrieval task, generally you're only looking for a single video or a single caption or item from the opposite modality. So given a video, you're looking for a single caption, or given a caption, you're looking for a single video. So how do you normally complete this task? Well, the standard approach is to use a cross-modal embedding. So you want to embed the two modalities close to each other. And we might have our video here and our caption. And the goal is to create a joint embedding space such that if the two items are relevant, i.e. the video and the caption correspond to one another, they are close together within this space. And you generally do this with separate embedding functions. So you have an embedding function for your visual domain, and then you have your embedding function for your textual domain. And this is generally also trained with a triplet loss, where you have your video, you might have your caption, which corresponds to that video, but then you might also have a caption which corresponds to a different video, and essentially you want to bring these two close together, and then your incorrect caption further apart, because it is not relevant to either of the other two. And then so this is a work from ICTV last year, and when we were looking at this, we've realized that actions tend to be formed up of these tuples or pairs of verbs and nouns. And this is something that we can very easily gain from the language modality in almost a very unsupervised way, and that's using parsing. So the caption here, I put the cup down on the counter, can be parsed into its constituent verbs and nouns. So we have put, cup, and counter. And in this case, we now want to generate some features for these words. And we actually use a feature extraction from a word embedding, such as word2vec, though more recent works tend to use BERT models from natural language processing. And you can see here we have a vector for our nouns, which we've just summed the representations for cup and counter, and we have a verb vector representation for our verb put. We also want to do the same for the video, and we use a CNN feature extractor here, and this is actually some other work that we've done at Bristol, which was a video audio action recognition CNN model, the details of which I'll give at the end. But again, we have a video representation as in vector form. And now we want to create our embedding spaces, and because we're disentangling our caption into its constituent parts of speech, we're going to create an embedding space for each part of speech. And in this case, we just have verbs and nouns. So we create a noun embedding with our projection functions, F and G. And then we have our triplet loss L here. And this will just learn the nouns and the videos themselves together, put the nouns and the videos themselves together. Similarly, for the verbs, we'll also create another embedding space, and it will learn two separate projection functions with a separate loss. And then overall, we want to still learn about the caption and how they relate to the video. So we want to combine these, this information together. And we do this in a relatively simple way, just by concatenating the outputs of the visual modalities and the outputs of the language modalities. So we have a final vectors for our embedded visual and our embedded caption. And then we have a final projection here just to sort out any inconsistencies from going between the two different spaces, as well as a final loss, which helps train the entire method. And we call this the joint part of speech embedding method. So how does it compare to other approaches? These are the results in the Epic Kitchens 100 dataset, or the one released this year. I've included random as a baseline, and this is the scores using the normalized discounted cumulative gain. And I won't go too much into this detail into this metric because of the time, but essentially we want to ensure that all of our relevant items are ranked high in the list and anything that's irrelevant ranked lower in the list. But as you can see, compared to standard approaches, which might embed using a single function, disentangling the caption into the verbs and nouns gives quite a nice performance for both the visual to text and the text to visual searches. And on this slide, so I talked before about how audio can help and the cases such as the closed fridge. And so when we did our video feature extraction, we actually used two different forms of features, ones which have been trained with the audio and ones which hadn't been trained with the audio. And we can see here that we get a nice boost of accuracy again for both video to text and text to video, simply by just adding in the audio features. And in future work, we want to further discover what else we can do with audio to help this embedding. And again, we want to kind of look into how language can also help this cross-modal embedding. So at the start, remember I talked to you about the unseen class of the small-eared dog, and this represented a zero-shot class. So generally when we're training models, we have a set of classes in training, and then we might have this smaller subset of classes on testing. So while we've not seen the instances in our testing set before, we generally have seen the classes that they represent. However, in the zero-shot case, we have a complete, well, we don't have any overlap between our training classes and our testing classes. So this might, if you think of the example before, you might think of like the dog, the Amazon rainforest in training, and then the small-eared dog in testing. So while we'd seen things that are similar, we hadn't seen the exact animal in testing. And so this is what we did. We created two sets, which we had zero-shot verbs and zero-shot nouns within the actions or the captions themselves. And then we tested our different methods on how they can deal with this zero-shot case. So this is a very challenging scenario because essentially you haven't seen what these videos contain before. And you can see the low scores from random. We have our CCA baseline here, which is a pre-deep learning baseline, as well as the two deep learning baselines here. And you can see that the best performance, again, is gained by disentangling the caption into its constituent parts of speech. So to conclude, language is how we as humans interact in the world, but isn't really natural for classification. And this is due to the problems with context and when certain verbs or nouns can be used. We find that language can give a lot of contextual clues without supervision, and this is due to the power of the word embedding models that we're using. So most of these are trained using Wikipedia, so you can download the entirety of Wikipedia and learn when two words co-occur. So most cases, such as like bowls and plates, these co-occur a lot, so they'll be given a high level of semantic similarity. And this is kind of what's helping us with that zero-shot case, right? Because we know what can be similar in this word or language prior, so we can help this for the zero-shot cases. And then finally, audio and language can benefit vision with this external knowledge. And this is very important for vision systems going forward. So thank you everyone for listening. Feel free to ask me any questions either now in the Q&A or by email at the list below. And then I've included some references of what I've been talking through on this work. So the retrieval embeddings have been the top one, and then the Epic Fusion, this is the CNN that we used for the audio recognition. Thank you.